Greetings everybody, this is Henri from the AXBlue support team. Welcome to this third part of our hands-on video about integrating an INS OEM in a vehicle. In this part, we'll see the integration through a mock-up vehicle. We choose to use an AUV. It will consist of 4 steps. In the video, we'll have first the mechanical integration. The second part will be about electrical integration. The third part will be some extra pro tips and more pro tips about powerful features that make your vehicle integration and your design very powerful. At last, I'll have Cor from RTS to provide us some user perspectives about his experience integrating the FinC3 OEM in a vehicle of his design. So for the mechanical integration in my vehicle, I have plenty of choice of design. Here I will make it very simple and will concentrate a little bit more on the axis and conventions and orientation of the unit. This AUV here is on the side, and I will fit my INS OEM kit like this. So I will choose to use still the same axis for IX1, but you see IX2 of the INS will become IX3 of the vehicle. For the electronic boards, I install them as I have room. Like I said in the previous part, I could choose to do like this or like that. Here I'll keep it simple and do like this. So now that I have properly integrated in my vehicle, I would have to fit it, take care a little bit of heat for power dissipation. Here I have metal plates. I choose to keep them so it will safe dissipate through your vehicle. We'll see in the electrical parts about power consumption. So let's say this AUV body is IX1 axis along this way and IX3 axis along this way. My unit is integrated kind of on the side. IX2 of the unit will become IX3 of the vehicle body. Let's go back to the web interface of the unit and configure this accordingly. So in the web interface, I'll go in the mechanical parameters and I'll choose to fit the unit accordingly. So we'll see that the attaching plate side is changing direction while the board side is still on the back of the vehicle. Here I didn't really prepare how it's gonna be this side or that side, so I will use it very visually. I just play with the different options and to see when I have IX2 of the unit becoming IX3 of my user interface. So I think that's gonna be this one. You see now visually on my user interface, I have the same that I have here. The unit is on the side, on this side, and I can validate the setting in the user interface by doing so. So now the user interface prompts me to restart the unit, which I will do. And so now, as the unit is rebooting, it is virtually, it was like this, and now it's virtually like this in the vehicle as I have a side view of my vehicle. So those 3 axes like this become like that with this change of configuration. It's very important for later mechanical integration because I will, for the purpose of the show, measure the offset to my USBL transponder. To proceed with the lever arm and offsets of my USBL transponder, I will have to physically measure accurately the lever arm from here to here to here along the 3 axes of the vehicle, because now my IMU, my INS is in the vehicle reference frame, and I will have to take a measure according to what we call at AXBlue the P point, so the center of measurement of the IMU subassembly. The P point is given to you through the schematic in the user documentation, and it's about a little bit on the board side here and a little bit in the middle here. So for the show purpose, I'll just use this to this and this to this for the two offsets. So to measure them, I use a ruler or here a ribbon tape to measure the lever arms. And so to make it very visual and to implement in the user interface. So that's 23 centimeters along AX1 axis. And around the middle here, that's 6 centimeters along AX3 axis. So now I will set them up inside the user interface for my USBL sensor lever arm. So I go to the input menu. I choose the USBL I previously configured. And if I scroll down the configuration, I will access the lever arm. So now I can set up a 23 centimeter as an offset. So you see it's 23 centimeter forward of the IMU. So it's about right. 23 centimeter forward of the IMU. AXV2, let's pretend it stays at a 0 value. We choose to work it in 2D to make the case study more understandable. And AX3 will be 6 centimeter. And you see again, it's very visual, 6 centimeter up the INS body. So it's about here, 6 centimeter up the INS body. So you see this interface makes it very visual, very easy for you to work in a little bit complicated situation, because by design I had to turn 90 degrees on the flank the IMU body, the IMU subassembly in my AUV body. About electrical integration, it will be about a bunch of things. First, about power. So now we should not anymore use our lab power supply. We should use the power lines from the AUV body. And it's important to remind that the power supply will be, grounds will be independent from the serial input-output grounds. For the purpose of this demonstration, I will keep this as is, and I'll simulate a wiring of USBL sensor over serial through this connector. For that purpose, I will need to prepare in advance specialist tooling. I'd like to show them to you today in this video, because those specialist tooling sometimes take a lot of time to order. So it's important to have them in advance, especially if you plan to have an agile vehicle integration. And so I have this tool here to put the wire in the pins, and I have this tool here to fit the pins in the connector. So I will need those two. I will need this connector, which is provided in the scope of delivery, and I will need a little bit of wire to wire my fake USBL sensor, and a little bit of pins to wire the pins. Likewise, in the user documentation, we provide you with the detailed input-output pin numbers and order. You can see here a small notch on this connector, so it will give you a very visual knowledge of where is pin 1 and pin 2 and so on. In order to proceed with the wiring, so I will use this tool here. I have to make sure it has the proper settings and the proper positioner, and then I have to fit here that tiny pin which has a direction into the positioner. as it is properly fitted, then I just have to prepare my cable of the right size. So there's an AWG number for that. And I fit the cable into the pin and secure by clicking to the end. Now my cable is fit. I can visually test by pulling a little bit and it's fine. And now I fit it in the right pin, so let's say this one. I can position it like this, and then with the tool, I'll fit the cable like this and press. I should hear a little click, you see? And now my cable is secure. So the last thing I have to do is to do the other pins and fit the cable in my connector here that I can secure here with locking sleeves. It's important to remember about this electronic design. When we conceived this product at iXblue, we wanted to provide you with the lowest current consumption, the lowest power draw. This unit is taking you about 12 watts because we wanted to keep in mind outstanding performances of navigation, but also autonomous vehicles requiring longer autonomies. For that purpose, the design of the electronic boards do not have any more optical isolation in between each ports. This makes, unlike the other iXblue product, that every input-output over serial share a common ground. It's not an issue in itself, but I'd like to remind that because sometimes it's confusing with the other products at iXblue. Just keep in mind the power ground is isolated from the serial ground and from the mechanical ground. So we give you the utmost flexibility for your AUV design in terms of electrical integration. You could consider, for example, in your own interfaces to have optical protections or protections of your choice of design. Last thing before we proceed is to see a little bit of more power user features. Some features that I think I need to show you that makes this product very much standalone OEM. So here it's about two other menus I'd like you to discover with me. The first one is what we call the advanced position filtering. So it gives me access to a lot of settings with the input sensors. Like we said, we can interface to a lot of sensors with this unit, and we give you access to advanced settings of those sensors into the algorithm of the processing boards. This allows you to maintain a very tuned design with your desired application. And so, for example, here I use the USBL case. So I'd like my vehicle to take in priority USBL position over GNSS position, for example. So I can set that up. And you can see that I can also filter my USBL. Sometimes out there USBL is a little bit noisy. Eventually I want to limit the input standard deviation of the USBL data. Or I would like to reject data that have too much of announced standard deviation. So this is exactly where I can set that up. So this is this page makes it very tunable for you for your vehicle design and integration. The other menu I'd like to show you is the simulation mode. This simulation mode allows me to virtually output data. So you see in this menu, I can set up a heading with a period and an amplitude value. By doing that, so let's do, I don't know, 30-degree heading over 30 seconds with 10 degree amplitude. And so now every 30 seconds, my heading will go from 20 to 40. And if I do that, I can do that on a lot of things: position, sensors, error message, status message. Now you can visually see my heading is changing, okay? It's simulated. And by the way, the system is telling me through a status message it is in simulation mode. But basically, it allows me to test the other components of my vehicle. For example, if I have a navigation computer that I want to test on output data of the INS, or if I have extra other sensors that will read data from the INS feed, I can very much test and simulate fake data in simulation for test purpose and integration purpose. It allows me to have the best design, the best integration possible of my vehicle. Now it's time for me to call Cor, and Cor will give you some very interesting user perspectives about his experience integrating exactly the same unit in his product, the Nemo. Cor, over to you.
Oh, thank you, Henry. Yes, I'm going to talk about the user's perspective of integrating the XBooth Fins 3 in the Nemo that you can see next to me here. I work at RTS, which is a company that was founded in 2002, and we are based in Norway, and we work with subsea electronics and developing subsea products. Looking quickly on the electrical level, we found that Fins 3 had high quality components in an enclosed electronic stack. The connectors were very robust, and that's a very good thing. And it was also easy to connect to it compared to many other OEM solutions. But we saw there was some issues with the documentation, that the Aristotle toolbox was not isolated. Yes, going over to mechanical, there was some issues there with that was not a standard hole for the dowel pins. The pins you used to orientate the unit very accurately. But also was laser cut the holes for the dowel pins, and that means that it's tiny bit of metallic inside the holes, and that's so we had to remove that to accurately fit the unit. Also another thing was that it was bended steel used in the construction, and it's difficult to get bended steel accurately. In terms of performance, it was beyond our expectations. It was much better. But we also see that the specification of the unit it's made for a wide range of aiding sensors from different manufacturers, and that means that these aiding sensors are of very different quality, accuracy. That will limit the specification. And the specifications are a deciding factor where you can deploy the unit. If you have very high accurate sensor, you have the best, it's calibrated for this area you're going to work in, and you have a very good deployment, you are going to have much better results. But you can't use it. The specification don't agree. Yes. Okay.
Yeah, thanks for. Yeah, it's indeed something we spoke a lot over our customer support exchange as you were, integrating the product. But I'm very happy you give us this user perspective. It's a little bit kind of what I said as well through this series of videos. about performances. I'm happy you report to us those outstanding performance. It's also the result of your outstanding integration. Thank you, Care. So to finish this video, 4 things I'd like to remember. This was a very easy and modular integration. We've seen we could integrate or interface many different ways. It was fast and easy to configure. Of course, it's a mock-up scenario, but the idea was to give you the feeling that under an hour, we can already play and configure this kit. Like we said, that there is those solutions, and we like to think it's a standalone integration, meaning everything's inside the unit for you to integrate in your vehicle. And also one of the things is that it's mass production ready. Should you have a fleet of vehicles you'd like to install with those products, we've made things we think easy for you. Thanks for watching this show, and see you soon in the 4th part with some tips and tricks about this integration. Thank you for watching.